to your second recorded lesson on probability, and today we're going to really focus on building on the foundations of finding the probability of simple events to finding the probability of multiple events and how we use a probability tree to do that. So let's start by looking at what tree diagrams do. So a tree diagram are a way of listing potential outcomes when we have multiple events. So we're not just doing one thing now, we're doing one thing and then another thing and then potentially another thing after that. So we use tree diagrams when we have multiple events. That might be rolling a dice and then rolling the dice again. It might be rolling a dice and then flipping a coin. It can be various things, but it's one event after the other, which is why it's so important that we are clear on what events we have in a question. Each branch in our tree diagram represents a potential outcome. So again, we need to understand thoroughly what outcome means so that we know what to put in our branches. So let's break it down with a simple question. So this is an exam question that we can have a look at to try and highlight these two things. So it says, here are 7 tiles. So you've got 7 tiles here. You've got 2 tiles that have got a 1 on them, here and here. You've got 3 tiles that have the number 2 on them, and you have 2 tiles that have the number 3 on them. And it says Jim takes a random tile. He looks at the tile and then replaces it. Jim then takes a second random tile. Calculate the probability that both the tiles Jim takes has the number 1 on them. And part B, calculate the probability that the number on the second tile Jim takes is greater than the number on the first tile he takes. So hopefully what this is going to show is the step up from what we were doing before when we're looking at one event. This question is definitely about 2 events. And the reason I know that is because they're talking about Jim takes a random tile and then he takes a second tile. So from those 2 pieces of information, I now have got 2 events going on. So if I put this question on its own screen, my 2 events now are event 1. Okay, is you pick a tile. And then event 2, in fact, let me do it over here so I can do them separately. Event 2 is I also pick a tile. They're the same events, but you're doing it twice, so you're picking 2 tiles. So for event 1, my possible outcomes, well, what could I get when I pick a tile? I could get a tile that's got a 1 on it, a 2 on it, or a 3 on it. In the very same way, when I pick that second tile, because I've put the first one back, it's almost exactly the same problem. So my outcomes are still, I could get something that's got a 1 on it, a 2 on it, or a 3 on it. And the associated probabilities, well, I can find them by looking at the diagram. So I know that these probabilities are going to add up to 1. I know that these probabilities are going to add up to 1. So the probability when I first pick it that I get a 1, well, there are 2 cards that have got a 1 on them out of a possible 7 cards. The probability of getting a 2, well, there are 3 cards that have got a 2 on it out of a possible 7. And the probability of getting a 3, there were 2 cards with a 3 on them, so that's 2 out of 7. And the probabilities here are exactly the same because you're doing exactly the same thing. You're just doing it one after the other. So that's how we would set up a problem when we have one simple probability. What we do now is we write this as a tree diagram. So it looks something a bit like this. I have event 1 is my first column and event 2 is my second column. And for event 1, I have 1, 2, 3 branches. So this tells me I'm going to have 3 branches. And in my second column, it tells me I'm going to have 3 branches. So this is telling me I've got 1, 2 columns, and each of those columns have got 3 branches in them. So with my columns, I've got 2 columns, 1, 2. So this one represents event 1, and this one represents event 2. So in event 1, what have we said we've got? We've got 3 branches, 1, 2, 3, because I could get a 1, a 2, or a 3. When I come to event 2, how many branches could I have? Well, each of these go off to 3 branches. And why do I know they go off into 3 branches? Because here, the outcomes in event 2 are 3 branches. So again, I could have got a 1, oh goodness, could have got a 1, a 2, a 3, a 1, a 2, a 3 again, or 1, a 2, a 3 again. So for each of those possible outcomes in event 1, I could also get a 1, 2, 3 again here. So that's what my tree diagram looks like. This first bit represents event 1, picking the first tile. So probability of getting a 1, 2 out of 7, the probability of getting a 2, 3 out of 7, the probability of getting a 3, 2 out of 7. And those probabilities match across here as well. So 3 out of 7 and 2 out of 7. 2 out of 7 for getting a 1, 3 out of 7 for getting a 2, 2 out of 7 for getting a 3, 2 out of 7 for getting a 1, 3 out of 7 for getting a 2, and 2 out of 7 again for getting a 3. So that's what your tree diagram looks like, and we're going to spend some time now focusing on breaking this down, so how you build a tree diagram and also how you find probabilities from it. But you need to have a clear picture of what this looks like and why we go and why we present it in that way. So that's our kind of bridge across what we've just been doing. So we're going to have a quick focus on, if you've got a tree diagram, how can you find information from it, and then we'll go back and look at how we actually draw those tree diagrams. So remember the number of outcomes. So here the number of outcomes, I had a 1, a 2, and a 3 in the first event. 1, 2, 3. The number of outcomes represent the number of branches you have, and the number of events, so event 1 picking a tile, event 2 picking a tile, represents the number of columns you have. So here, number of outcomes represent the number of branches, number of events represent the number of columns. So if we look at this example, in the car on the way home, I go through 2 sets of traffic lights. The probability of a red light for each is 2/3. Draw a tree diagram. Well, you've got to be really clear what your events are. So let's have a think about events here. So my first event is the first traffic lights. And my second event, call that event 1, event 2, is going through the second set of traffic lights. Okay, because you can't go through 2 sets of traffic lights at exactly the same time. So the second set of traffic lights, so that looks like this. So automatically I know I'm going to have 2 columns because I've got 2 events. So column 1, column 2. In those columns, I now need to know how many branches there are going to be. And I only know how many branches there are going to be by knowing how many outcomes there are for each traffic light. So when I look at a traffic light, we're going to pretend in this case, when I look at a traffic light, you have 2 options, red and green. So here I would have red and green. I know sometimes you can have amber, but we're going to simplify it. So I get red and green, and here, red and green. Okay, so for each of these columns, each of these 2 columns, I should now see that there are going to be 2 branches in each. 2 branches. Okay, so let's look at what I mean when I say that. Well, 2 columns look like this. There is column 1, so that's event 1. And there is column 2, so that's event 2. Okay, and in each of these columns, there are going to be 2 branches. So I start here and I've got 1, 2 branches because I could have red or green. And again here, each of these are going to span out to give 2 branches. Red and green again, red and green again. So each of those have got 2 branches. And the probabilities, well, I haven't done that final line here, but the probabilities here, it told me the probabilities of a red light is 2/3, which means that green must be 1/3 because they always add up to 1. And the same here, 2/3, which means that that's 1/3 because they always add up to 1. So red is 2/3 and 1/3, 2/3 and 1/3, 2/3 and 1/3. And you've got your tree diagram. So you're not going to have a go at doing this. It says, remember, the number of outcomes represent the number of branches, the number of events represent the number of columns. So it says, Tom has to take 2 penalties at the end of the match. The probability of him scoring is 2/5. Draw a tree diagram. So I want you to pause the video and write down the same setup as what I've done. How many events have you got? what are the different outcomes for each event, and then what are your associated probabilities. So pause now, and let's get that information down. Okay, welcome back. So let's have a look at how you set this up. So your events, when you've got two events, so event 1 is when you take penalty number 1. And then event 2 is he's taking 2 penalties. So event 2 is the second penalty. The different outcomes you could get, well, they're the same for each event. You either score or you miss. Okay, so you score or you miss. And then the associated probabilities, well, the probability of him scoring is 2/5. So that guy there is 2/5. It must add up to 1, so that leaves you with 3/5 left. So that one there's 3/5. Same again over here. So you've got the probability of scoring, 2/5. The probability that you miss, 3/5. So this must add up to 1. Now you're ready to draw a tree diagram. So we drew a tree diagram. We know that we should have 2 columns because you've got 1 event here and 1 event here. So I should have 2 columns. And in each column, you're going to have 2 branches because you have 2 branches because you've got 2 different outcomes. So I start here and I go 1, 2. I could score and I could miss. And then for each of those, I could score and miss again. So score and miss, score and miss. There's my tree diagram. The probability in event number 1 that I score was 2/5 and that I miss is 3/5. The probability in event 2 I score is 2/5 and I miss is 3/5, and again 2/5 and 3/5. So I've got my tree diagram set up. Now, once you've got your tree diagram, you need to know how to fill in that information. So if we look at this tree diagram here, hopefully you'll be able to quickly see how you could fill in the missing information. This is a very, very, very common exam question that they give you because it shows that you understand how tree diagrams work. And remember, the way they work is this line and this line represent the only 2 outcomes in this experiment. So those 2 lines must add up to 1, which means if you've got 0.4 here, this one must be 1 minus 0.4, so that one must be 0.6. Same thing going on here. So you've got 2 branches coming from the same point, 2 branches coming from the same point, so they must equal 1. So therefore, if this one's 0.7, what would you have left? 0.3. Finally, same again here. Branches, so here, branches came from the same point, must equal 1. If you've got 0.3 here, that leaves you with 0.7 that must go there. So that's how we can fill in gaps of information. So you know how to turn this. I've given this to you now in fractions. I want you to have a go. Pause your video. Can you think about those 2 branches? They must add up to 1. So what is the missing fraction? Okay, welcome back. So hopefully we can see that if you've got 2/5 there and they've got to add up to 1, you need to get it up to 5/5. So you must have 3/5 left over. Okay, and again, here and here, they must add up to 1 because they're branches from the same point. If you've already got a quarter up here, you must have 3/4 left here. And again, here and here, they're coming from the same point, so they must add up to 1. If you've already got a quarter, you're going to need 3/4 left to go there. So that's how we can fill in missing information, remembering that branches always represent all possible outcomes and therefore they must add up to 1. So final thing we need to have to do in our part, we'll bring it all together, is you've got to find the probability of 2 red lights. We've got to find the probability of an actual question. So what's the probability of 2 red lights? So all we do is once we've got our tree diagram tick, you look at the question, 2 red lights, and you go down the end of your branches. So you go down here and you tick any situation where it meets your criteria. So my criteria for this question is 2 red lights. So let's have a look at anything that meets it. So if I go to here first at this point, and I think about what's happened, to get to there, I've gone red and red. So that part there represents red, red. And the question's asked me, what's the probability of 2 red lights? So this one meets my criteria. So I'm going to give it a tick. Now let's have a look at this one. This one has gone red, not red. So it hasn't met my criteria because my criteria is 2 red. And I've got a red and a not red. Now let's have a look at this one. This is not red and red. So again, it's not meeting my criteria because what's happened, I've gone through a not red light and then I've gone through a red light. And finally, this one here, this one has gone not red and not red. So I haven't hit any red lights. So again, it doesn't meet your criteria because your criteria is 2 red lights. So we now look at all those ticks and crosses and we only care about the ones that have got ticks on them. So I take my ticks and I'm going to multiply down the branch. So when I go down a branch, you multiply. So here I would say the probability of red and red is equal to 0.4 times 0.7. So 0.28 is your answer. So when you travel down a branch, you multiply. If you're collecting branches together, you add. There's only one branch that meets my criteria here. So I've gone down the branch, 0.4 times 0.7 to get me that 0.28. Okay, let's have a look at another example. So in this case, we've got a full tree diagram and we're just focusing on actually answering the question. So it says, what is the probability of only stopping once on my journey home? So only stopping once on my journey home. So that means 1 red light, okay? So that's the same as saying 1 red light. So I would like you to have a go. Pause the video, copy down this tree diagram, and then I want you to go to the end, so the end of the lines, and I want you to tick and cross any of those lines that meet the criteria of 1 red light. Pause your video now and come back when you want to see the answers. Okay, welcome back. So we're going to look at how many combinations mean that I stopped once. There's 1 red light. So let's look at the first one. So the first one's here, that's red and red. So that means I've stopped twice. So it doesn't mean my criteria, so I'm going to put a cross by it. I've stopped twice and I'm only stopping once, 1 red light. Next one, I've got here red and then not red. So I've stopped once and then I haven't stopped. So this does meet my criteria. So this should have a tick by it. It is met. Next one, not red and red. So I've gone through the first light, but then I have been stopped. So I've been stopped once by a red light. So this one gets a tick. And then the final one is not red and not red. So I haven't been stopped at all. Nobody stopped me. No lights have stopped me. So this one doesn't meet my criteria because I want to stop at least once. Okay. So not red and red and not red are my 2 combinations. So now I've got 2 branches that meet my criteria. 2 branches. So you start by doing exactly what we did before. You've got your 2 branches, 1 and 2. So you're going to times down the branches. So for branch number 1, you would do 0.4 times 0.3. So that gives me 0.12. For branch number 2, I would do 0.6 times 0.7. So 0.42. Once you've got all your branches times, to collect your branches together, you add. So you go down your branches by multiplying. So if I go in this direction here, I'm always multiplying. But if you're collecting branches, you're always going to add. When we collect branches, we add together. So now I've got final answer 0.54. 0.54. Okay? So let's have a look at how they're going to ask us in Hegarty. So this is a question that's come from your Hegarty clips this week. It says, there is a bag filled with 5 blue and 4 red marbles. A marble is taken at random from the bag, the colour is noted, and then it is replaced. Another marble is taken at random. What's the probability of getting 2 reds? So we are now going to build all of this together. We've got to turn our question into a tree diagram and then find a probability from it. So Let's start by setting out how we do every single probability question. We're going to list the first event, we're going to list the possible outcomes, and we're going to list the probability, and then we're going to do it for the next event and for any further events. So what's the thing I do first in this question? I take a marble from the bag. Okay, so I take a marble from the bag, and what are my possible options? Well, I could get blue, or I could get red. And my probabilities for those, well, blue is 5 out of a possible 9 and red is 4 out of a possible 9. So when I take that first marble, that's what happens. I could get a blue or a red, and my probabilities are 5 over 9 and 4 over 9. So what happens next? Well, the colour is noted and is put back in the bag, and another marble is taken at random. So my second event is actually identical to the first. I take a marble. What are my possible outcomes? Well, again, I could get blue, I could get red, and what are the associated probabilities? Well, they're exactly the same because you put that marble back in. So blue is still 5 over 9 and red is still 4 over 9. But from this information, I can now tell you that there are going to be 2 columns to my tree diagram, and each column is going to have 2 branches coming from it, 2 branches. So let's build it. So I've got something like this, 1 column, 2 column. So I start here, 2 branches, which could be blue and red, and here, out of each of these 2 branches, blue, red, blue, red. Let's put some probabilities on it. So for event 1, so this is event 1, the probability of blue was 5 over 9, and the probability of red was 4 over 9. And then for event 2, the probability of blue was 5 over 9, so that can be a 5 over 9, and here is a 5 over 9, and the probability of red is 4 over 9. So like that, 5 over 9 and 4 over 9. So you've got your tree diagram. Now let's look at what the question is actually asking for us. What is the probability of getting 2 reds? 2 reds. So here's now where you go down your branches, and I need to see you either tick or cross them. So this first branch is blue and then blue. So this should have a cross by it because I'm looking for 2 reds. So blue and blue doesn't count. Then I could do blue and red. Again, it's not meeting my criteria of 2 reds, so I'm not going to do it. Then I've got red and blue. Doesn't meet my criteria of 2 reds, so I'm not going to do it. And the last one, red, red. Now that one does meet my criteria because I want to get 2 reds. So red, red works. So I found my branch. So my probability of red and red will be equal to 4 over 9 times 4 over 9. Because when we go down the branches, so when I'm going down here, I'm multiplying. And when I multiply fractions, I times across the top, times across the bottom, so I should get 16 over 81 as my final answer. Okay, so that's how all this question comes together. Building your tree diagram, calculating the probability. So let's finish with you having a go at one yourself. It says a bag is filled with 6 blue and 5 red marbles. A marble is taken at random from the bag, the colour is noted, and then it is replaced. Another marble is taken at random. What is the probability of getting 2 of the same colour? So I'd like you to get up to the point where you've drawn your tree diagram. Press play so you can check your tree diagram is correct, and then we'll move on to the final part of the question. So pause now to draw a tree diagram. Okay, welcome back. So we should have set out our tree diagram just as we've done before. We've got our first event, which is to pick a marble. What are your outcomes? So your outcomes are blue and red, and the associated probabilities, well, blue is 6 over 11 and red is 5 over 11, and that's your first event. Then we have a second event because you put the marble back, so event 2, and you pick another marble. So it's the same title, you're going to pick another marble. Your outcomes are the same, blue or red, and actually the probabilities haven't changed either because you have put the marble back in, so you're repeating exactly the same experiment. But what does it tell you? You've got 1, 2 columns, and in each of those columns, you're going to have 2 branches. So in column 1, you've got 2 branches, but actually in column 2, you've also got 2 branches. So let's draw our columns here. There are your columns, event 1, and there's event 2. So in event 1, we said there were 2 branches, here and here, blue and red, with the probability 6/11 and 5/11. And then you can also have 2 branches coming out for each of those, because event 2 has 2 outcomes, blue and red, and then again blue and red. You repeat it. So I've got 6/11 and 5/11, 6/11 and 5/11. Okay, so each of those have got 2 branches. Now check that you definitely got that tree diagram, because we're ready now to actually answer the question. So the question says, what is the probability of getting 2 of the same colour? So I'm going to go down my lines. Let's start here, 2 of the same colour. So my first line is there and there. It's blue and blue. Does it meet my criteria? Yes, it does. So that can have a tick on it because I've picked 2 marbles of the same colour, blue and blue. Right, next one. I'm going to go down here. This is blue and then red. Blue and then red. They're different colours. Does it meet my criteria? So it gets a cross on it. Next one. I've got red and blue. Again, not meeting my criteria because they're not the same colour. And the final one, red and red. Now, this one does meet my criteria because they are the same colour. So this time I've got 2 branches that are meeting my criteria, blue, blue, and red, red. So for blue, blue, when I work that out, I'm going to go down the branches. So it should be 6/11 times 6/11. So I get 36/121. And for this branch here, I'm getting 5/11 times 5/11. So this is 25/121. So if I want to bring them together, so if I want to group the branches together, I finish this question off by saying, okay, the probability of the same colour is this branch, the 36/121, or the other branch, the other outcome. So when I'm collecting branches, I'm going to add the fractions. And again, this fraction is lovely and easy to add because you've got the same denominator. So because you've got the same denominator, you have the same denominator in your answer. And you only need to do 36 add 25. So we should get 61/121. So that is pulling this whole topic together. Now, we're not doing any more knowledge on this for the rest of the week. We're just going to practice and practice and practice. So if you haven't answered this lesson or you want to go through it again, watch it through again, build the answers, have a go at the answers yourself, and then press play to make sure you understand it. And then watch one of the other follow-up lessons, which have got the same knowledge, no new knowledge, but just different style questions in them. Well done for today. Make sure that you go ahead and demonstrate your knowledge by having a look at the Hegarty, because Hegarty will take you through some really similar questions to what we've just done here. And remember, that's clip 361 on Hegarty. Okay, take care. Bye-bye.